Number 20, which equation best represents the relationship between x and y in this graph? We're looking for linear relationships, and these are all in slope y-intercept form. So we have an algebraic equation here, and all we're going to do is we're going to plug in a few numbers for x and find our y, which will create a coordinate point. And if these lines are true, both the points, when we substitute 0 and 1, should land on this line. And if they don't, it doesn't work. If they both land, it does work. So let's start with A. So what we're going to do is we're going to substitute 0 in, and we substitute 0, it's 3x minus 2, so 3 times 0 is 0, minus 2 gives us 0, negative 2, and then 1, 1 when we plug that number in there. So we get these two coordinate points and we plot them on the graph. It looks like our blue point lands on the line, but our red one does not. So if it's going to be true, they're both going to land on the line, so A does not work. Let's look at B. We plug in 0, we get 3 for our y. We plug in 1, we get 2.5 for our y. Let's go ahead and put those on the graph, those 2 points. We've got the red and the blue. The red does hit 0, 3. It's the y-intercept. It hits on the line. But 1, 2.5 doesn't. It's not on the line. So B doesn't work either. Let's go to C. We're going to plug in 0. We get 0, 3. And if we plug in 1, we get 1, 1. Let's plot both these on the graph. We have 0, 3 does land on the line, and 1, 1 does land on the line. So it looks like they both land exactly on the line, so this one does work, so C does work. Let's take a look at D. Let's put 0 in. We put 0 in, we get 1.5. If we put 1 in, we get 3.5. Go ahead and plot those on the graph. It looks like neither of them actually hit on the line, so that one does not work either. So in order for these to work, both points have to land on the line. So which equation best represents the relationship between x and y in this graph? C. Y equals negative 2x plus 3.